Now let's look at how the transmission shift map can be changed and its impact be assessed on the vehicle. Let's go to the transmission subsystem. The upshift map is a map with vehicle speed and accelerator pedal position and determines when the vehicle shifts from the first to the second gear, second to third, third to fourth, fourth to fifth, and fifth to sixth. And the downshift map does the vice versa. It determines when the vehicle will shift from sixth to fifth, fifth to fourth, fourth to third, third to second, and second back to first. The upshift and downshift map, just like any of the other curves in PowertrainLive, are specified as a table with the gear number and accelerator pedal position. Now our baseline fuel economy for this vehicle in this configuration is 16.68. For our scenario, I have created a new upshift map. This is the existing upshift map in PowertrainLive, and this is a new upshift map that I've created based on the existing shift map. To change the upshift map, just go into the data, select all the data, delete, and put in the new upshift map. For this, let's create a new scenario called a different upshift map. With this new upshift map, we will be able to determine how the vehicle will perform under a different aggressive upshift map and what the effect on fuel economy will be. Now let's run the simulation with this new upshift map. Once the simulation is complete, let's look at our results. We can see that the fuel economy now has changed to 16.62. Not only that, but we can overlay both the results on top of each other and look at individual parameters of the transmission. Here I am overlaying our baseline scenario run with the different upshift map. As you can see, since we've only made a small change in the upshift map, there are only small changes in when the gears would change. However, the orange line shows our baseline scenario for shifting, and the blue line shows the new upshift map. You can change other parameters inside the transmission subsystem as well, such as gear ratios, final drive ratio, the transmission upshift and downshift maps, the gear shift times, some of the other advanced parameters such as the certain transient parameters, the torque converter characteristics. In addition to that, you can also, from a thermal management perspective, add in a transmission warm-up profile and see the impact of not only the fuel economy, but also the transmission performance with different transmission warm-up. In this case, for our drive cycle, we have assumed a warm transmission and therefore assumed a flat 90° C warm transmission. In addition to that, you can also change the transmission efficiency map. The transmission efficiency is a function of engine speed, gear, torque, and temperature. Or for certain types of testing, you can also impose the transmission shifts from test data. PowertrainLive's transmission submodule provides numerous inputs as shown, allowing you to do different types of studies on different parameters of the transmission.